Good morning, everybody. Today we're going to be talking about a very important topic called Slope-Intercept Form. And this is going to combine together this idea of slope, y-intercept that I've kind of talked about. Today we're going to really kind of dive more into that. And you're going to see, again, today's assignment should be pretty easy once you understand what you're doing. But it's also very important that you understand it, because this is something you're going to use time and time and time again. Linear equations are just, they're a very big part of algebra, okay? And so is in being able to interpret and understand linear equations, you have to be able to use something called slope-intercept form. So that's what we're going to work on. So this first question here says, find the y-intercept of the following equation. Simplify your answer. We have y is equal to 9x plus 5/9. Okay? So let's I want to first talk about this with just the equation on its own, and then we're going to look at the same question with the graph, and then I'll go through a few more examples after that. So first off, every linear equation can be written like this. Now, as you get older, I know in 8th grade we're kind of working on this a little bit. You're going to see messier equations that might not look like this at the start, but there's different tricks you can do to move things around, combine things together. Now we're going to keep it pretty simple here in 7th grade, because we're just kind of learning what's going on. So this is called slope-intercept form. This y equals mx plus b that I wrote right here. Slope-intercept form. Let me even write that. I know it takes a second, but I want you guys to see it. You have slope, and you have the y-intercept just right in the equation, and it's in slope-intercept form. So what exactly does that mean? Well, it's actually pretty simple once you have an equation in slope-intercept form, because you could just read off the slope, read off the y-intercept. So m is going to represent our slope here. So this is our slope. And remember, slope is this idea, this constant of proportionality that we're talking about. Remember, constant of proportionality, I'm not going to write all that out, but we called that k, right? That was also our unit rate, so that's our slope. Let me actually write that over here. So this is kind of like our k. I'm going to put quotes there because it is a little different, but that's how you can think about it. So our slope is like that k we've worked with. Remember, y is equal to kx. Remember, that's kind of how we started a lot of this, proportional graphs. Well, now we're working with linear graphs, which aren't necessarily proportional. In basically all functions, instead of k, we're going to use m, and that represents slope. Don't ask me why they pick such weird letters for these. It's just what it is. M does represent the slope. So in this case, our equation that we have written right here, well, in this case, our slope, your slope's always that number right next to x. Now that number can be positive, it can be negative, it can be a fraction, it can be a decimal. Sometimes you'll see it where, you just have a number in the denominator. You'll see a bunch of different types of equations, in the IXL and as you get older. So in this case, our y-intercept here is going to be 5/9. And I know I didn't write that down yet, but That's what B represents, our y-intercept. So this is our y-intercept here. So you see, you just kind of match them up. The number next that you're multiplying by x, that's your slope. The number that you're adding or subtracting, that's your y-intercept. Okay? So in this case, find the y-intercept in the following equation. Simplify your answer. There's not really anything to simplify. You just write in 5 over 9 there. Now, I do want to take a look at the same thing in Geogebra. So we have y is equal to 9x plus 5 ninths. What does that mean? Okay, so Geogebra is this nice website I kind of used for yesterday's video. You just go here, you can press start graphing, and you can actually just type in an equation just like this. So let's see, we have y is equal to 9x plus 5 over 9. Oops. Okay. So let's zoom in here. I wonder if I can... Okay, notice it's counting by halves here. So 5 over 9, let's see what that's equal to. I think you can just type that in. Yeah, so that's about 0.56. Okay, so notice that this graph here for this equation, y is equal to, what was it, 9x plus 5 ninths. Notice our y-intercept, remember that's when x is equal to 0. Okay? Our y-intercept is when x is equal to 0. So that'll be right here. Y-intercept okay? Now that's when x is equal to 0. Right, because we look at our x-axis, well, that's when x is 0, that's when it's on the y, and we see that that's going to be, well, x is 0 at the y-intercept, and it's going to cross through at 5 ninths. So that's what the y-intercept is telling us. Slope I'll talk about, we've already talked about it before a little bit, but there is more to it. I kind of want to make sure that we know what this is first, because this is actually a little simpler. Your y-intercept, that's just where it's crossing the y-axis. Remember, this is our y-axis here. This is our x. And the y-intercept, the x is always 0 there, so you're always going to go to coordinate for it. It's when y is equal to 5 ninths. So that's what we see right in our equation here. Now I'm going to do a new example. I'm going to do my own actually. One that's a little simpler. Okay, so what if we had, actually let's do this. Let's do 2x plus 2. Yeah. Actually 2x plus 1. There we go. Alright, so now we have this equation here. This one's a little bit different. So in this case, we have y is equal to 2x. I'm going to fill in the numbers in a second. So let's do blue. Blue will be our slope here. Let's use pink for our y-intercept. Okay, so remember this is our slope. and this is our y-intercept. Okay, sorry, I'm a slow writer. So we know we just talked about that our y-intercept is where it crosses the y-axis. So that's going to be right here. Let's see, that our y-intercept is 1. So that means it's crossing, it has a point at 0, 1 on the y-axis. Now our slope is a little different. Remember, our slope, this is like that constant of proportionality. So what you see is just like with that, every time x is going over by 1, we see that y is going up by 2. And I know if you count on the grid, it's technically 4, but remember, this is counting by halves here. So from here to here is 1, from here up to here is 2. Okay? And if you actually just keep going with the graph, you're going to see that it's the same thing every time if you keep going. So add 1 to your x, we add 2 to our y. Now I know we're running out of space there, but if you kept going, you would go up 2 from 3, so you'd get your next point up here at, you'd get it at 2, 5. So say you weren't sure, like where did these numbers come from? What's going on? Okay, remember I said that with graphing you can always make a table of values. So let's look at this one because we haven't worked with, a function quite like this yet with graphing. So I'm going to keep it simple. Let's put in 0. Actually, I'll use a different color though. Let's do 0, 1, 2. So this is going to be our x. And then we'll say y is equal to 2. Right, 2 is our slope, times x. Okay, so this is just so far exactly what we've done before, but now there's just one extra thing. We're adding the y-intercept, we're adding plus 1. So now, when you fill in the y's, you're going to do 2, plug in x there. I'll write that after. You'll see in just a second. Okay, so remember with the other assignments last week, we would do 2 times whatever x is. Okay, well, we're doing that again. In this case, x is 1 for the second row. For the third row, x will be 2. So now we just have 2 times 0 over 2 times 0. That's just going to be 0. So we're going to have 0 plus 1, or we're going to have 1. And then remember, that's not a surprise though. Oops. That's not a surprise. We already said that was our y-intercept right here. 0, 1. So we should have expected that. Now let's see. Let's see if the second point is here though. Well, 2 times 1. We know that's 2. So we're going to get 2 plus our y-intercept, so plus 1. We'll get 3. And then down here, We have 2 times 2, that's 4. 4 plus 1, 5. So you can see this is actually no longer proportional, right? Because you can't just multiply x to get y, but it's really the same type of thing. We're just multiplying 2 times x, because that's a rule for our equation. Then we're adding 1 to it. Okay? And a little pattern that you might notice is that each time, just like before, right, just like we found with proportional graphs, we're adding 2 each time. You're adding the slope each time. Plus 2 plus 2. If you kept going, well, now we know the pattern. We're just adding the slope each time. So we'll add 2 to 5. So the next one would be 7. Okay. For 4, you would add 2 to the 7. So 4, 9. And you could keep going and going. And that's because this graph here is always doing the same thing. Alright, so let's do a few more examples, and then I'll try to wrap up the video to keep it from being too long. It is a very important topic, though. This is something we'll come back to. We're not going to talk about this stuff too much before the test, but we might come back to it after we've had a chance to work with one-step, two-step equations that you'll see in a few weeks. So, okay. Find the y-intercept of the following equation. Simplify your answer. We already did this one. It is 5/9. Find the y-intercept of the following equation. Oh, remember the number next to x, 5, that's our slope. So this must be our y-intercept. Find the slope of the line. Oh, that's the number next to x. This time it's a fraction. So we put 5/3. Now, let's see. There's a couple I want to talk about. And now they're not showing them, but okay, so I'll just write them real quick, what I want to cover. So what if you had y is equal to negative x plus 10? What's the slope? Well, the slope, remember, is going to be the number in front of x. Now, we just have a negative sign that's not a number, but remember, negative x, it's really the same thing as negative 1 times x. Okay, so we say that the slope in this case would be negative 1. So our slope m, remember that's representing slope, that'll be negative 1. Our b will be 10. Our y-intercept will be 10. B represents the y-intercept. Now, another example, just real quick. You might see something like this. Put the negative back in there. We have that over this, and then we'll do plus. Actually, we'll do minus 2/3. Okay, so what's the slope? What's the y-intercept? Okay. So in this case, our slope, we have a 6 down here. You have a negative in the top. Okay, well, that means that it's just negative 1 over 6 then. So negative 1/6 times x is what this says. Okay. So It doesn't matter. You can put this in the numerator, you can put it over here, but it's negative 1/6. If this was positive, it would be a positive 1/6. So hopefully that's pretty simple now. Our y-intercept in this case, we're subtracting 2/3. So when you're subtracting, remember subtraction and negatives, they go hand in hand. So they basically mean the same thing. So in this case, our y-intercept would be negative 2/3. So this is where this graph would cross the y-axis. And then this refers to our k, our constant of proportionality, all that we've worked with before. So make sure I know this was a long video, but make sure you watch the Math Antics one from yesterday. I'm posting it again today in case you didn't. It's just such a good video, and he puts together all these great pictures and everything that I don't have time for. I don't really know how to do anything of that high quality. So just please make sure you watch it. They're really well done. He really does a good job explaining it. So please give him a chance if you don't like watching those videos. You'll find them very, very helpful. So that's all I have for you guys today. Please take care and goodbye.